For number 20 and 21, they were a little bit more advanced. Forgive my writing here. I didn't have time to rewrite it. This is like a proof. And you're taking the cosine of an a minus b and proving that it's equal to sine of x. And it's not just a minus b, it's pi over 2 minus x. And pi over 2 we know, of course, is 90. So what we're going to do is go to our reference sheet and pull off the formula for cosine of a minus b. For a, whenever we see a's, we're going to substitute 90 degrees. Whenever we see b's, we're going to substitute x's. So it's cos a, cos b, plus sine a, sine b. So you can see for the a's, I put 90s. That's a 90. Forgive me for that sloppiness. And for the b's, I put x's. I didn't do anything with this side. When you're working a proof, when you're working an identity, you only work one side. When you've simplified that side as much as possible, it should look like the other side. So now these are quadrantal angles. You can either use your unit circle, your trig graph, or go right to the calculator. The cosine of 90 is 0. The cosine of x is just cosine of x. Bring down the plus. The sine of 90 is 1. The sine of x is just sine of x. Again, bring down the equal sign every time there's a new line in the proof. Anything times 0 is 0. Anything times 1 is itself. And this makes me happy because 0 plus sine of x is sine of x. That's exactly what we were trying to prove. So sine of x is indeed equal to sine of x, and my proof is completed. So that's like an abstract one with a difference formula. For number 21, it wants us to find the exact value of cosine of 105. I can't find the exact value of cosine 105. Even if I express this as a function of a positive acute angle, it would be minus the cosine of 75. That's still not going to help me. But 105 can be rewritten in terms of exact value angles. It could be rewritten as 60 plus 45. Now I just take out my handy dandy reference sheet and I find my cosine of a plus b. Wherever I see angle A, I'm going to put a 60. Wherever I see angle B, I'm going to put a 45. So here we go. A, B, A, B. I put sets of parentheses under each one, bringing down the subtraction sign. I go to my tic-tac-toe exact value chart. Cosine of 60 is 1/2. Cosine of 45 is radical 2 over 2. The sine of 60 is radical 3 over 2. The sine of 45 is radical 2 over 2. I can't just type this into the calculator because it's irrational and they want the exact value. I'm not going to get an irrational value from the calculator. So I have to do my old-fashioned multiplication. Multiply the numerators across, the denominators across, I get radical 2 over 4. Bring down the subtraction sign. Multiply the numerators across, the denominators across, I get radical 6 over 4. Now you're almost done. It's almost completely simplified. You just have to make sure that since they do have the same denominator, you can indeed add the numerators. In this case, subtract. So it's radical 2 minus radical 6, which can't be combined because they're not like terms, all over 4. If you type this into the calculator and you type the original in, cosine of 105, it would be equal to the same hideous decimal.